Hello everybody, welcome to this vlog. My name is Satya. So today, as part of this vlog, I will discuss about difference between switch, router, hub, and bridge. Okay. So before we go on in this particular vlog, I would like to mention that. These are the whatever I wrote on the whiteboard. These are the different features that a telecom infrastructure equipment supports. So what I want to say is, for example, if you buy a networking equipment, it can be a router, it can be a switch, it can be a bridge, or it can be a hub, right? So depending upon what you want, you buy a particular network equipment. So let's start dwelling into what exactly each one does. First, I'll write a switch. Switch. So, in a general term, what does a switch mean? Switch means either we can turn on or off, right? In electrical terminology. So we say turn off the switch, turn on the switch, like that. So basically, it is switching from one state to the other state. So in the same way, switch in the networking equipment means that it is switching the packets. So whatever packet that you send IP datagram through this, for example, if it is a 4-port switch, so we call 1, 2, 3 and 4. So 4 ports are there in this switch. Let's suppose we connect port 1, this is port 1, port 2, port 3, port 4. We connect this port 1 to PC1, port 2 to PC2, port 3 to PC3, and port 4 to PC4. Let's suppose we connect the topology in such a way, right? So all these personal computers want to communicate with each other. As I told you, each personal computer will have a network card, which is an Ethernet network card, which is identified by a unique MAC layer address, which is called as MAC address. MAC address is 6 tuple long and it is separated by colon, right? So yeah. So then for example, let's say PC1 as a MAC address 00:11:22:33:44:55, and let's keep the first 5 tuples as same, the last one as 6, this one as 7, this one as 8. So let's see what is the functionality of switch now. PC1 sends a packet from its Ethernet card to PC4, right? So packets are usually sent Ethernet packet or IP packet. Usually in our daily internet usage, the packet will have an application layer, network layer, IP layer, MAC layer, and the physical layer, right? So we are talking about here is MAC layer. So when we want to send a packet, and here as I discussed, or I want to tell you that PC1 will have one ARP cache, which is called as ARP cache. Okay, so here ARP cache will store information about an IP address mapped to a MAC address, right? As I told you, switches are usually in the last hop, Routers are in the intermediate ops, right, which route the packet depending upon the IP address. Here, each op, right, within a local area network, all the forwarding or packet processing, packet forwarding is done using MAC addresses. So PC1 knows his MAC address, which is 00:11:22:33:44:55. He wants to communicate with PC3, for example, which ends with :77. Right? Now, first he checks here. He wants to send an application packet. Next layer below it is IP layer. Let's suppose it has IP address x.x.x.x. Its IP address, and this is PC3 is having address x.x.x.x3. This is x1, for example. Right? Let's not dwell too much into IP address because switch does not understand IP addresses. Right? Switch is an entity which works at MAC layer. Now it checks for reaching x.x.x.x3. Does it have an entry in its ARP cache? If it is there, then you will send the packet populating the destination MAC address. If it is not there, you will send an ARP broadcast to resolve the IP address to MAC address. So what he will do is PC1 will construct an ARP header, then he will put the details in the ARP header saying my IP address is x.x.x.x1. I am looking for an address called as x.x.x3 and my MAC address is ending with 55. This is what he will tell, and he will broadcast it, and the broadcast MAC address is ff://ff://ff://ff://f. So all F's. It is 255.255.255.255. Once he sends a address with broadcast destination address, he will broadcast that ARP packet to all the ports except one, because it received on the one, right? He is the source of the packet. So he will broadcast to here, here, and here. So which PC will respond? They will respond. PC3 will respond unicast, saying that. And first thing what you need to keep in mind is, as soon as this ARP broadcast package is received on port 1, you will note it down that port 1 is mapped to MAC address ending with 55. So he has an entry here, that is port 1 belongs to 55. Then PC4 will reverse the packet and say that x.x.x.3, sorry, not PC4, PC3 we are contacting, right? So PC3 has IP address x.x.x.x3, and he will respond to the ARP broadcast message received. None of the other packets will respond because none of them have the same IP address, right? Only PC3 has x.x.x.x3, which was put in the ARP broadcast ARP query. So PC3 will send an ARP unicast message. He will say destination MAC address as this ending with :55 and source as this. As soon as he receives that ARP unicast message, 3 will populate :77 as the port mapped to 3, right? So then he will switch, because already he will check the switch MAC table, and the MAC address 55, which is the destination MAC address of the ARP response packet, is mapped to port 1. He will bridge the packet or switch the packet to PC1. So that's how the switch works. So to repeat, if a packet with a certain MAC address is received by a port on the switch with a particular MAC address as destination, you will immediately put the source MAC as the port 1 is having source MAC, and that is colon 55, right? You received a packet on port 1 with the source MAC as colon 55, 6 tuple long, but we are only taking for our time saving. We are just taking the last tuple, that is 55. So 55 is mapped to 1 as soon as this is the source MAC address. Then port 3 receives the ARP response with source MAC as colon 77. Immediately updates the switch MAC table as port 3 maps to colon 77. In the similar way, depending upon the packet, Ethernet packet received here, they will update the switch MAC table. So that's how the switching takes place. So that's what it is, switch. It is called a switch. So it's clear now that a broadcast Ethernet packet will have a destination as FFFFFF, but source will be the source of the packet, which is the Ethernet card address, which is generating the particular Ethernet packet. As soon as it received on the any port, whether it's a broadcast or unicast, it takes a source MAC address and maps it to that port to switch back the packet in the reverse direction. And if it's a unicast also, source address is taken and mapped to that particular port. So this is nothing but a switch. Switch is nothing but switching the packet depending upon the MAC address. It will not know anything about IP address. Right here, even though we said we are resolving the IP address to MAC address, the actual switching happens in the MAC level. That is MAC address, using MAC address only switching happens. So then next one is router. Router usually is a terminology used to identify a network equipment which has more than one interface, and it is capable of doing IP networking or IP routing depending upon IP routing depending upon the IP addresses at the layer 3 on different interfaces. So let's put a router. Router can also be like this. So these are the port or interfaces, right? So the line shows it's an Ethernet connection or an SFP fiber connection. So we can route the traffic. The physical layer can be anything, but we are concerned more about at the IP level. So let's suppose we connect PC1, PC2, PC3, PC4. Let's suppose in the same way we want to communicate from PC1 to PC3 through this router, layer 3 router. Okay, so everybody should be familiar with OSI model. So OSI model has 7 layers, TCP/IP has 4 layers: application layer, network layer, transport layer, application layer, transport layer, network layer, MAC layer, and the file layer. Okay, so the most important 4 layers are application, transport, network, and MAC layer. So now the router will be operating at network layer. Let's suppose PC1 has an IP address 192, or for example, let's take IP address as X. IP address is 4 tuple long, each separated by a dot. X dot, X dot, X dot, X1, X dot, X dot, X dot, X3. Okay, my address is colon 55, as we remember and from the last example, switch example, colon 77. So that is a MAC address. Now if PC1 wants to communicate from x dot x dot x dot x dot x1 to x dot x dot x dot x3, you first check its PC1 will check its routing table to reach xxx x dot x3, how to reach it. So to understand the router very well, we need to understand the subnet concept really well. So what is a subnet? Subnet mask defined. Subnet is a network of few hosts or some hosts, right, sharing the same network ID. So for example, if you have a subnet mask of 255.255.255.0, when you have such kind of address subnet mask, it is known that 255 is translates to ff dot ff dot ff dot ff. So that is the hexadecimal representation. If it converted to sorry, the last one is 0, right? So 0 0. So if you convert the hexadecimal to the binary or bit level information, ff translates to 1 1 1 1 1 1 1 1. In the same way, dot 1 1 1 1 1 1 1 1. In the similar way, you can continue. Now you need to understand the logical operations and or very well to understand the subnet mask, especially AND gate. So let's suppose to identify the network ID, we need to take the first, there are 4 tuples, right? So here it will be like, to expand it here, it will be 1 1 1 1 1 1 1 dot 1 1 1 1 1 1 1 1 dot 1 1 1 1 1 1 1 1 dot 1 1 1 1 1 1. Sorry, this is 0 0 0 0 0 0 0. Okay, so this is how each tuple is separated by dot, as I shown here. This is in binary representation. Now let's suppose we take 192.168.0.1, right? So if we put here 192.168.0.1, okay. So now you need to do an AND operation between these two. I put here the decimal representation for the actual IP address because I don't know the hexadecimal conversion of 192. I mean, we need a calculator to convert it, but since I don't have a calculator in handy, so I just wrote it. So in AND, for example, 192 will have some of them as zeros, right? So when you AND it, 111 with 192 will become 192 only. All ones with 168 maps to 168 only. All ones with 0 will map as 0 only. But all zeros with 1 will map as dot 0. So the network ID is 192.168.0.0 is the network. The last tuple does not matter. If we change the second last one as all zeros, then the network ID will be 192.168. That's all. If you change till here, then the network ID will be 192. Rest of the thing will be interface ID for layer 3. I know this is little complex, but you need to keep in mind that the actual IP addresses are represented using decimal. They are converted into hexadecimal and binary, and then first we need to convert them into hexadecimal and then into binary, right? So then we AND the actual IP address to get the network ID. So for IP address of x.x.x.x1 and IP address x.x.x.x3, the network ID would be with a subnet mask of 255.255.250, network ID will be x.x.x, x.x.x, which is same. So any network, any route with the same network ID will be routed within the local area network. If the network ID is different, for example, if the source has one network ID and the destination address has one network ID, then they will use the default gateway. Default gateway means they'll go through the router, right? So first thing is, immediately you can correct me, how can a router have same address on two different ports? It's not possible. A router should have different addresses on different ports, right? It can't have the same address, same network ID address, right? So here we need to take it out. It is x.x.x.x3 here and x3.x3 here. So x.x.x and x.x.x3 both are different. Okay, so then what it has to do is, if it was sending the packet within the link within the local area network to this particular port, you would have used the default gateway, default route. How do you define a default route? So sorry for that mess up. So the default route is defined as 0.0.0.0/0, and it points to a default router which is x.x.x.x3, what we defined in the previous thing. So in the correct thing, we were using 192.168.0.1, and the default IP address, default gateway IP address will be 192.168.0.2. But we were sending the packet to, for example, x3 PC is there, right? So that is 192.168.1.1. So network ID is, if the subnet mask is 255.255.255.0, all Fs, this is the network ID. So for x3 PC, this is the network ID. For x1 PC, this is the network ID. When you are transmitting from this address to this address, PC knows that it's a different network ID, so he will use the default route, which is 192.168.0.2. Then default router will forward the packet to the next x3 PC, right? So router usually routes the packets depending upon IP address, right? So just example to understand the network ID better. If subnet mask is 255.255.255 and your IP address is 192.168.0.1, with this subnet mask, how many hosts are possible in this network, and what is the network ID? Since 255, 255, 255, 255 is present in all the tuples. The complete IP address is a network ID. That means to say in this subnet there is only one host possible, which is 0.1. Let's suppose we take out this 255 and put here 0. Then the network ID will be 192.168.0. If you take out this one and put 0 here, the network ID would be 192.168. If you take out this one and put 0, then network ID would be 192. So that's how the subnet mask, in a very simple way, I can explain, right? So it's much more complex because you can have 254, 253 like that subnet mask. So that is a separate class in itself, because in this class I'm focusing on the difference between switch, router, hub and bridge. So we explained switch. Switch only operates on MAC addresses. It stores, maps a MAC address to a port, and that's how it switches the packet between different ports. Router routes the packet depending upon the IP address. So that's why I explained, right? With respect to a generic example, I took x dot x dot x1 and x dot x dot x3, right? And for example, I took a real IP address as 192.168, 0.1 and 192.168, 1.1, how the communication happens. So this is what the router definition is. The router does routing depending upon the network layer, which is based on IP address. Now, what is hub? So in a simple English language, hub is where everybody meet, right? So in the same way, hub will have, for example, 4 ports. Example I am taking, it can be any number of ports, 1, 2, 3 and 4. The difference between hub and switch is there is no comparison between hub, switch and router. Router is at the layer 3, hub and switch are at the layer 2, which is MAC layer. So if you send a packet, Ethernet packet here with a MAC address, it will bridge it to all the ports. Whichever port has the matching destination address, he will respond. For example, if the matching address came from 3 will respond, and that's how it does the communication. There is no intelligence in the hub to store the MAC addresses, right? So it's very simple. So Ethernet, source, packet, a certain MAC address, a destination MAC address. One receives it, he doesn't store the MAC address pertaining to source as we did in the switch. He will only check that Ethernet packet is received, and he will switch, he will bridge it to 2, 3 and 4. Okay. Now all the ports will receive the packet. Now for example, 3 responds. He reverses the packet, right? So here whatever source we used here will become destination, and whatever destination we use will become the source. He receives the packet, he also switches it to all the ports except 3. Then you will see the response also received on all the things. Hub is usually used in the network topology to capture the Wireshark packets. For example, if you have a streaming server running between 1 and 3 ports, you can connect a laptop or a PC to 2 and you say start the Wireshark trace or start the TCP dump if it is Linux, and Wireshark if it is Windows. On second port, you listen what is going on in port 1, port 2, port 3, port 4, because whatever packet comes in port 1, 2 also can see. Whatever packet that comes on 3, 2 also can see. Whatever packet comes on 4, 2 also can see. So that is the main use case for hubs, and it will make the traversal of the packets little slow, right? So it's not that fast, right? It's not good or very ideal for high communications, right? So we usually use in our network setups to capture the packets, what is going on in the other ports, to debug the problems. So then comes bridge. So bridge is nothing but a connection between a set of ports, port 1, 2, 3, for example, 3 ports are bridged, if we say, then bridge sometimes can be dumb, act like a hub, sometimes can be intelligent, little bit intelligent, and act like switch. If it is dumb, it doesn't have a MAC address learning capability, MAC address learning is disabled, then whatever packet is sent here is always sent to 2, is always sent to 3 also in this bridge. Okay, if MAC address learning is enabled on the bridge, then if a packet received on 1 source address, will check and it will immediately put that for this port 1 the MAC address is, for example, dot colon 55, right? And then he forwards it to, initially if there is no, a MAC address is empty, he will forward it to all the ports. Once he sends back the address to the bridge has a bridge cache, he receives it on port 3, for example, the response. He knows for destination 55 is, then also he will populate for 3 source address, it will map colon 77 and he'll put it in the bridge MAC table and it is mapped to 3 port. So bridge can act as hub and also act as switch, right? If the MAC address table learning is disabled, then it's a pure hub. If the MAC address learning is enabled, then it acts like a switch depending upon the MAC address. So this is what the difference between switch, router, hub and bridge. Switch, it's a layer 2 element, it switches the packets depending upon the MAC address. It learns the MAC address, maps it to a particular port depending upon the source MAC address, it maps to a port and then it switches the packet. Router, it's an IP address, layer 3 component, and it routes the packets depending upon the IP address. Hub, it's a pure hub, pure bridge where no MAC address learning and no intelligence is present, no learning capability will be there. Whatever port 1 receives, 2 also receives, 3 also receives, 4 also receives, 5 also receives, 6 also, depending upon the number of ports on the hub. It is usually used for capturing or mirroring the traffic to debug the network problems. Bridge can be switch and also as a hub. If the MAC address learning is disabled, hub is called as bridge is called as hub. If the MAC address learning is enabled, then it's called as switch. Bridge acts like a switch. So this is what I want to discuss with you, friends. Please subscribe to this channel and wait for you can know more network related content that can be that will be put in this particular blog in this channel. Okay, thank you, bye.